learning never stops. Ayan, good afternoon, Ortanistas. Good afternoon, grade 10 students. Welcome once again to Science Matters, where learning never stops, our live synchronous class for the week 2 of quarter 2 in Science grade 10. Ayan, so nabalik-baliktad yung mga sinabi ko. Hindi yung usually line ko eh. No? Anyways, good afternoon sa inyo. Thank you so much for tuning in. At sa ating mga naka-tune in na ngayon, ayan, good afternoon sa inyo, sila Mary Ann at si Ryan, mga usual natin na tagapanood sa ating live streaming every week. So siguro yung iba wala pa sa ngayon kasi naging Monday, no? From our usual Tuesday live streaming, naging Monday ang live streaming natin today because of course, holiday po bukas. And I hope na alam niyo yung reason kung bakit holiday po tayo bukas. Of course, it's Andres Bonifacio Day. Alright, and so with that, before tayo mag-move on sa ating kumustahan, no, may I greet, of course, our principal, ever-supportive principal of the Dasmariñas North National High School, none other than Dr. Francis Kenneth D. Hernandez. Of course, our head teacher, one of the science department, Sir Nicanor Reyes, our master teachers, Ma'am Janice Reyes and Ma'am Mary Ann Castro. Hello po sa inyo. And to all the teachers of the science department na patuloy na nakatune in every week, no, and every live streaming mula kanina pang grade 7, mga patuloy na sumusuporta. Good afternoon po and hello po sa inyo. And this is the last live for today. And I hope that everyone is fine, everyone is all right. I hope everyone is ready for our lesson for today, week 2 of quarter 2. Sige po, magkamustahan po tayo. Ayan. Good afternoon sa iyo, Sir Ralph, Sir Nick, and of course, Ma'am Sally, good afternoon. Marvelyn, good afternoon sa inyo. At sa mga classmates nyo na hindi pa nakatune in ngayon, sabihin nyo na mag-tune in na, although nakapag-send na rin ako ng mga links sa ating mga GCs. Kumusta ka? Kumusta kayo? Kindly comment the emoticon of your choice of how are you feeling today. The usual thing that we used to do, no? Yung, especially, no, gusto ko makakita ng mga tapos na sa task kasi last week pa naman naka-open yung task kasi our lesson for this week is actually good for 2 weeks since last week pa kung saan nga nakasama nga natin si Ma'am Mary Grace Marinda. Ayan, gusto ko rin nga palang batiin ng ating mga MDL grade 10 science teachers. Of course, si Ma'am Marinda na dapat sana ay nakasama ko rin today. Of course, si Sir Elpidio Vidalio, si Ma'am Jennifer Soperal, at si Ma'am Janet Coronacion. Hello po sa inyo. Good afternoon. I hope na nanonood din po kayo dahil nanonood po ang inyong mga estudyante sa mga oras na to. Alright, so ayan, si Ryan daw ay masaya. Gusto ko makakita sana ng mga tapos na sa task. Meron kayong mga nakatapos na sa task. Si Marveline ay masaya. Kanina, I was checking the submission bean for the ODL students. At meron akong mga nakita na mga full na nakapag-submit na mga 14 students pa lang na tapos na for the weeks 1 and 2 task. Thank you so much and pagpatuloy nyo lang po no, yung pag-manage ng timing nyo wisely so that you can finish the task on time. Alright, o yan, masaya din daw si Sheena at si Mary Ann. Good afternoon sa inyo. Kakonti pa lang ang viewers natin ngayon, no? Bakit kaya? But anyway, move on tayo. Alright, so sige po, let's move on. Last week, we've been talking about the electromagnetic waves. So, meron ako ditong short video clip. Ito nga yung nagpapakita ng electrons that is moving and this moving electron is actually creating electric field. Okay po? So, yung mga waves na yan na nabubuo no, from that moving electron and this moving electron is actually connected to a circuit. Ayan po. And nagkakreate nga siya ng electric field. Although, alam niyo po ba na ito ay nagpo-produce din ng kanyang magnetic field. And so, electric field producing magnetic field producing electric field, itong dalawang to pag nagsama, ito nga yung tinatawag natin na electromagnetic wave. Ayan, last week pa natin pinag-uusapan. Pinili ko lang tong figure na to, class, tong short clip na to para mas maintindihan nyo that this wave is actually propagating through space and even through medium. Alright? And it is the combination of the oscillation of electric field and magnetic field. And for this afternoon, ipagpapatuloy pa natin ang ating lesson sa patungkol sa electromagnetic wave because our most essential learning competency is still compare the relative wavelengths of the different forms of the electromagnetic waves. Kung last week, nabigyan tayo ni Ma'am Marinda ng hints about sa history ng each of the members of the electromagnetic spectrum, ngayon naman ay talagang ikukumpara na natin ang mga wavelengths ng bawat isang members ng electromagnetic spectrum. And I have prepared a video for us to learn more about this. Here we go, guys. Watch this. Good day, students. Today we have here a plasma ball. Now, what do you think will happen if a fluorescent tube will come near this plasma ball? Let us observe what will happen. That's right. The fluorescent tube lit up. Let's try another one. Now, how are we going to explain this phenomenon? How did this fluorescent bulb light up in the presence of our plasma ball? Let's answer this question. Our most essential learning competency is to compare the relative wavelengths of the different forms of electromagnetic waves. The alternating voltage of about 2 to 5 kilovolts at the center of this plasma ball creates electromagnetic waves with a frequency of about 30 kilohertz. The arcs of the plasma act as antennae, meaning that the extent of the electromagnetic field surrounding the ball is significantly larger than the bounds of the glass globe. Bringing the fluorescent tube near the plasma ball allows the electrons inside to be accelerated by this field, and these moving electrons constitute the electric current, which causes the bulb to light up. This demonstrates that an electromagnetic wave can be used to accelerate particles. Recall that electromagnetic waves are waves composing of oscillating electric and magnetic fields, propagating through space, carrying electromagnetic energy. All of the electromagnetic waves travel at the same speed, the speed of light, which is 3 times 10 raised to positive 8 meters per second. But how do these waves differ from one another? They have different wavelengths and frequencies. How do we distinguish wavelength from frequency? Remember that wavelength is the distance from one crest to the next crest or one trough to the next trough, and it is usually measured in meters. On the other hand, frequency is the number of cycles per second or the number of waves passing a point in a certain time. It is usually measured in hertz. To understand frequency and wavelength further, let us try this simulation from FET Colorado. So here in our simulation from FET Colorado, we will be explaining the difference between wavelength and frequency. So we have here a string with red and green beads, and it is set to oscillate automatically with the loose end. And we also have here the ruler, which will help us measure the wavelength, and the frequency reading is found right here. So all we need to do with this simulator is to adjust the frequency to which this string will oscillate and observe our ruler and measure the wavelength of each wave. So first, let us set our frequency at 0.5 Hz and let us see the measure of its wavelength from the ruler. So when the frequency is 0.5 Hz, the wavelength is 7 centimeters. Now, what would be our wavelength if our frequency reading is at 1 Hz? The wavelength decreased to 3.5 centimeters. What about when the frequency increased to 1.5 Hz? At 1.5 Hz, the wavelength is 2.3 centimeters. How about when the frequency increased to 2 Hz? As the frequency increased to 2 Hz, the wavelength decreased to 1.75 centimeters. Now let's try to move the slider to increase the frequency to 2.5 Hz. Now the wavelength as measured by the ruler is 1.4 centimeters. The electromagnetic spectrum is a whole range of electromagnetic waves in order of increasing frequency and decreasing wavelength. This means that as you go from left to right on the chart, the wavelengths get smaller and the frequency gets larger. An inverse relationship exists between the size of the wave and frequency. Remember that all waves travel at the same speed. The equation for speed is wavelength times frequency. Since the speed of all electromagnetic waves is constant, with a value of 3 times 10 raised to positive 8 meters per second, then the wavelength and the frequency has an inverse relationship. Whenever the frequency increases, the wavelength will decrease, and whenever the frequency decreases, wavelength will increase. Now let us discuss each member of the electromagnetic spectrum. Let's start with radio waves. Radio waves have the longest wavelength and the lowest frequency. Wavelength can go from 1,000ths of meters to 0.001 meter. Number 2, microwaves. Microwaves have wavelengths ranging from about 1 meter to 1 millimeter, corresponding to frequencies between 300 megahertz to 300 gigahertz. Both radio waves and microwaves are used for radar, sending sound, pictures, cell phones, cooking food, and satellite transmissions. Number 3, infrared waves or heat waves. These waves have shorter wavelengths from 0.001 meter to 700 nanometers and with higher frequency. Infrared is used for finding people in the dark and in your TV remote control. Number 4, visible light. Visible light is what we can see in the electromagnetic spectrum. Wavelengths of visible light go from about 700 nanometers, or the red light, to 400 nanometers, or the violet light. The frequencies are higher than infrared waves. Number 5, ultraviolet. Ultraviolet have wavelengths from about 400 nanometers to 10 nanometers. The frequency, and therefore the energy, is high enough with UV rays to penetrate living cells and cause damage. Too much UV can lead to sunburn and skin cancer. However, we need UV to produce vitamin D in our bodies. UV rays are easily stopped. Although humans cannot see UV light, bees, butterflies, and some small birds and rodents can. Number 6, X-ray. X-rays have wavelengths that are from 10 nanometers to 0.001 nanometer. They have enough energy to penetrate deep into tissues but are stopped by dense materials. They are used for looking at solid structures such as bones and bridges and for cancer treatments. Lastly, gamma rays. Gamma rays have the shortest wavelengths of about less than 1 trillionth of a meter, therefore the highest frequency, and therefore they carry the most energy. These are the most damaging to tissues. They are hard to stop. You would need a 3 to 4 foot thick concrete wall to stop them. Now, what are the different functions and applications of each of the member of the electromagnetic spectrum? That's what we're going to find out next week as we continue our discussion in electromagnetic waves. This is Ms. Rocks, only here at Science Matters, where learning never stops. Ayan! Good afternoon uli sa inyo at sa mga estudyante kong humabol. Ayan, sila Sheena, masaya daw sila Mary Ann, Krishaline, ayan, si Michiro, Parang bago sa akin si Michiro. From 10 Paterno. Ay, nga pala, may mga bago ng sections. At gusto kong i-take your opportunity para batiin muli ang aking 10 Magbanwa. I hope they are watching right now. Ayan, si Sino from 10 Aquino, si Randall at si Charlie. Ayan, at si Randall from 10 Paterno, si Charlie from 10 Aguinaldo, si Earl ng 10 Abad Santos. Hello sa inyo. Na ano lang ako sa mga ODL, no? Kasi parang wala silang choice kapag sync time, sync time. Pero yung mga MDL natin, they can always go back to the link. But huwag kayong mag-alala guys. Kahit na feeling nyo hindi medyo pantay ang treatment natin, no, sa ODL and MDL, lagi nyong isipin na you are favored pa rin. Alright. So, again, no, sa ating discussion for this afternoon, for our video lesson, I hope na nagustuhan nyo. Ang ating focus is to compare the relative wavelengths of the different forms of the electromagnetic waves. And to summarize the video lesson, so I hope na intindihan nyo po ang ating electromagnetic spectrum. May I show again the electromagnetic spectrum? Ayan. So, baka may nagtataka, ano po yung electromagnetic wave? Ano yung electromagnetic spectrum? Yung mga electromagnetic waves class, sila yung mga radio waves, microwave, infrared, visible light, ultraviolet, X-ray, and gamma ray. At tinatawag natin silang, pag sila ay tabi-tabi, no, sama-sama sila, ay spectrum na ang kanilang pinaglalagyan. Kumbaga, sabi nga ni Ma'am Marinda sa sa kanyang definition last week, it's a wide range of no, yung collection po nung EM waves, no, na sunod-sunod po sila actually. Kaya nga hindi po sila inimbento. They are discovered one by one because they are really in the same spectrum lang po, na magkakaiba lang po ang kanilang wavelengths and frequency. At yun nga yung pinag-uusapan nga natin this afternoon. So let us compare further. So ang ating okay, let me show my next screen. Ayan. So if the list of the waves are this, the radio wave, microwave, I want you to memorize the EM waves according to this order na po. So radio wave, microwave, infrared, visible light, ultraviolet, and X-ray. And when it comes to the wavelength, tatandaan natin that the longest wavelength is always the radio wave. So, okay lang no, kahit medyo mababaw pa lang, because next weeks to come, ipapaintindi naman namin sa inyo what are the functions and applications of these waves. Basta ang lagi lang po nating tandaan for today, the longest among these EM waves is the radio waves, and of course, the shortest is the gamma ray. Kaya yung arrow na yan ay papataas, it's because papahaba mula gamma ray up to radio wave yung ating wavelength. At pinakita naman sa video kanina ano yung difference ng wavelength sa frequency, no? Tandaan natin, ang wavelength ay yung sukat nung crest sa susunod na crest. So yun yung ipinapakita nga ng simulator ko kanina. I hope na-appreciate niyo yun. At kung hindi niyo masyadong naintindihan, nagkaroon ako doon ng parang 5 trials, no, ng pinabago ko yung frequency, at nakikita naman natin as we increase the frequency, the wavelength is decreasing, lumiliit yung size ng wave kapag dumadami ang ating frequency. Kaya nga, ang ating susunod na column there is about the frequency. Now, in comparison, the lowest frequency will be the radio wave kasi nga siya yung may widest na wavelength, no, longest wavelength, and therefore siya rin yung inaasahan natin na mababa ang frequency dahil wide yung wavelength niya. So, isang ganun lang siya ng frequency. Pwedeng isa lang or isang cycle lang, ganyan. While the gamma ray with the shortest wavelength, sobrang liliit, no? Kasing liliit na ng mga bacteria, sila naman yung may highest frequency na halos hindi mo na makita that the wave is actually moving like that. And hindi ko masyadong nabanggit, pero medyo, no, kung mapakinggan yung maigi yung video ko kanina, nabanggit ko rin doon na the frequency is actually directly proportional to the energy. Remember that all waves carry energy. Pero paano natin malalaman kung mataas ang energy dala-dala ng wave or kung mababa? Ayun po ay maikukumpara natin sa frequency. Tandaan, kapag ang frequency ay mataas, especially katulad niyan, yung gamma ray, with the highest frequency, siya rin yung may I'm sorry! Di ko nakita yan. Oh my God, kinapi-paste ko. I stand corrected. Ngayon ko lang nakita. Gamma ray should be the highest energy. Kinapi-paste ko from the radio wave. I'm so sorry, guys. So, the third column, right there, the energy, the lowest energy is the radio wave. That's correct. But the highest energy, kaya nga yung arrow natin is going down pataas, no? Pataas na enerhiya ay papunta sa gamma ray. Should be the highest energy. I'm so sorry, I stand corrected. Let me correct that later on. And of course, the penetration, ito, hindi ko masyadong nabanggit sa video kanina yung salitang penetration, pero nabanggit ko doon kanina sa gamma ray, nung dinidiscuss ko yung gamma ray, na ang hirap niyang i-block, ang hirap niyang i-stop, because it's really penetrating, nakaka-penetrate siya sa katawan natin. Kung ang X-ray hanggang muscles, no, binablock lang siya ng mga dense material like our bones, no, ang gamma, talagang nakaka-pass through anywhere, kahit sa mga bakal. Okay, so, kaya binanggit ko nga kanina doon kung ilang meters ang kailangan mo para ma-block mo talaga, ilang meters ng bakal or concrete ang kailangan mo para ma-block mo ang gamma, because it's highly penetrating, tumatagos sa kahit na anong material, most of the material. Mas madidiscuss pa natin yan in the next weeks to come. So, yan ang summary ng ating comparison. Kung mapansin nyo, class, kino-compare lang talaga natin yung compare the relative wavelength. Pero hindi kasi natin pwedeng i-compare lang yung wavelength ng mga EM waves. Kaya we are also comparing the frequency against the energy and against the penetration. Actually, in the next weeks to come, meron pang ionization. Okay, so pag-uusapan naman natin yan next week. Basta tatandaan nyo that the wavelength is inversely proportional to frequency. Kapag papataas ang wavelength, papahaba, okay, lumiliit naman ang frequency natin. And of course, hindi ko nabanggit ito sa video, our next slide is about the relationship nga ng dalawa, the wavelength and the frequency. At pag pinag-multiply nga daw natin yung dalawang yan, will give us the speed. The speed of wave or the speed of light. Actually, lahat daw ng members ng ating electromagnetic spectrum, the radio wave, microwave, etc., they are all moving at the same speed in vacuum, ha. Tandaan natin, ha. Pare-pareha sila ng bilis kapag sila po ay nagtra-travel sa vacuum or sa space kapag walang medium. And that speed is equal to 3 times 10 raised to positive 8 meters per second. Alright, so kaya ang formula natin ay ganyan. That the V or the speed of the wave, speed of light talaga yan for letter C, pero ilalagay na natin siya na V or the speed of the electromagnetic wave is equal to wavelength, so yan yung lambda, times frequency. Okay, baka sa ating mga MDL na nanonood ngayon, nagtataka sila, bakit may ganyan-ganyan sa lesson ni ma'am? Wala po niyan sa module. Meron po kasi sa ODL. That is why gusto kong i-discuss ito. So, 3 times 10 raised to positive 8 meters per second is equal to the wavelength times the frequency. And so, kapag po kukunin natin, kunyari sa mga ating mga problems ay tinatanong, since the speed is constant, ang pwede lang itanong sa mga problem ay kung gaano kahaba ang wavelength or gaano kalakas ang frequency. Alright, so if we're asked to find the wavelength, sige po, we are going to divide both sides by frequency, both sides. Alright, and then we will cancel the frequency right there. And so therefore, our new formula will be wavelength is equal to 3 times 10 raised to positive 8 meters per second divided by the frequency. Okay, yan po ang ating formula. Ngayon, kapag naman frequency ang tinatanong, babaliktarin lang natin yung dalawa. At ito nga yung nagpapakita na the wavelength is inversely proportional to the frequency. Pag sinabing inversely proportional, when one is increasing, the other one is decreasing. Let's try a problem. Isa lang po. So, what is the wavelength of the wave from the plasma ball? Yung kaninang dinedemonstrate ko sa experiment ko kanina sa video. What is the wavelength of the wave from the plasma ball that accelerates the electrons in the fluorescent tube if its frequency is 30 kilohertz? Alright, so of course, ang given po natin dyan, nakita nyo, isa lang, no? Frequency of 30 kilohertz. Pero ilalagay na rin natin automatically ang V or the speed of the EM, which is 3 times 10 raised to positive 8, kasi kahit wala siya sa problem, automatic na nandyan yan because all speed niya is moving at the same all EM is moving at the same speed. Alright? And our frequency is 30 kilohertz. Now, hindi natin magagamit yung 30 kilohertz right away because it's not family with the meters per second. So, we are to convert that. Alright? Moving on. So, 30 kilohertz will be multiplied to 1000 hertz divided by 1 kilohertz. And so, therefore, our new frequency, kinonvert lang po natin, no? I'm sorry, nag-move ang aking mga lines dyan. We are to cancel the kilohertz there. Okay, our new frequency is 30,000 hertz para ma-divide po natin ang ating mga given. And so moving on to our formula, we'll have, of course, speed is equal to wavelength times frequency. And since we are looking for the wavelength, therefore, wavelength is equal to the speed divided by frequency. And applying this formula to our given, no? Substituting our given to this formula, we have wavelength is equal to our speed of 3 times 10 raised to positive 8 meters per second divided by our frequency, which is 30,000 hertz. Ayan, pakita natin yung 30,000 hertz. Okay, so nakita nyo, ma'am, 30,000 hertz po ba yan? So, kinonvert ko na rin siya into scientific notation. I believe, no, tinuturuan kayo sa inyong math how to convert big numbers and small numbers into scientific notation. Since we have 3 zeros right there for 30,000, then therefore we have 3 times 10 raised to positive 4. At mas madali nating madidivide yan. Of course, 3 divided by 3 is 1. And of course, when we are dividing same base with different exponents, we are to subtract. So 8 minus 4, therefore we have 10,000 meters. So na-cancel na lang natin dyan yung seconds. Sige ma'am, paki-next slide po. Paki-next. Yan. Pinakita ko lang dito sa side kung paano naging meters. No? Yung meters per second divided by hertz. Ayan. So, paki-screenshot nyo na lang yan dyan because I'm running out of time to discuss that one by one. Pero yan yung explanation paano naging meters na lang yung ating unit. Anyway, kahit hindi nyo masyadong mag-grasp yan ngayon, tandaan nyo na ang wavelength ay distance, therefore, meter po talaga ang ating unit for measure. Alright, so hindi na ako nagbigay ng problem for frequency, pero sa inyong mga activity ay may problem for frequency. Ayan, pero halos similar din naman ang inyong solution pag babalik rin nyo lang yung position ng wavelength and frequency. Alright, that's all for today. Let's check your understanding of our lesson. Sige po, I have 5 questions for here. Ayan, sabi po ni Sir Nick na nanonood po sa atin ngayon ay siya daw po ang teacher ng Paterno. Ayan, nanonood po ang teacher niyo, yung mga nakatune in na mga Paterno students. Nakatune in din ang teacher nyo, kaya magpakitang gilas kayo. Let's wrap up our activity for our lesson for today. Number 1. Which has the longest wavelength? A. Radio wave, B. Infrared, C. Ultraviolet, and D. Gamma ray. Ano kaya dyan ang may pinakamahabang wavelength? So kaya nga ang advice ko kanina ay i-memorize nyo na lang yung members ng spectrum in order. No po, kasi hindi ko naman kayo ma-require na i-memorize yung mga wavelength and frequency ng bawat isa. Kahit ako po, hindi ko sila memorize. I need the table. Pero dapat alam niyo yung pagkakasunod-sunod nila so that we can easily compare these things. So what are our answer? Pakilagyan nga po ng number 1. I'm so sorry. Pero thank you, may mga answer na. Si Sheena, sabi niya letter A. Si Mary Ann, letter A. Si Saino, sabi niya radio wave po. Si Justin, number 1, letter A. Ang tama si Justin. Pakilagyan po ng number. We have Michiro, letter A. Saino, letter A. Letter A. Vina, letter A. Marvelin. Ayan, naulit lang po ang mga pangalan. And you are all correct. The answer is radio wave. That's right. Longest wavelength. Moving on. Number 2. Nagmamadali na mag-overtime na naman. Which has the greatest frequency? Letter A, ultraviolet. Letter B, microwave. Letter C, infrared. And letter D, X-ray. Ayan. So siguro hinahanap niyo yung gamma. Kasi sabi ko kanina, yun ang greatest frequency. But among the choices, which is the greatest? Doon lang tayo mag-focus. Baka sabihin niyo, ma'am, wala po dyan yung sagot. It can always have the answer kasi nandiyan pa rin naman sila. Okay? So, ano kaya among these choices have the greatest frequency? Kumabol si Ryan sa number 1. Sabi niya ay letter A. Tama ka, Ryan. Thank you. Number 2, pakilagyan po ng number and then yung letter of your choice. Number 2, wala pa or baka delayed lang po ako. Ayan, si Justin ay nangunguna for number 2. Sabi niya ay letter D. Si Saino, yan, letter D din ang sagot ni Saino. Si Charlie, si Sheena, si Michiro, lahat sila ay nag-answer ng letter D. Si Vina ay nag-answer ng letter D. And you are all correct. The answer is letter D. In the absence of gamma ray, the highest frequency na sa mga choices na yan is the X-ray. That's correct. Because it's next to gamma ray. Alright, number 3. Which has the least energy? Pinakamababa namang enerhiya. I said a while ago that the frequency is directly proportional to energy. A, ultraviolet, B, microwave, C, infrared, D, X-ray. Pinakamababang energy. Ano po kaya? Ayan, umabol naman din si Mary Ann, si Marvelin, si Alex, si Ryan, at si Earl. Nagsagot sila ng letter D sa number 2. You are all correct. Thank you so much. Ayan, nanonood din yung mga MDL teachers, kaya natitake note nila yung mga participation nyo sa discussion natin this afternoon. What about number 3? Alin kaya dyan yung may least energy? Pinakamababang energy. Aha. Ayan, nangunguna na naman si Justin. At ang sagot niya ay letter B. Sinusundan siya ni Sheena, ni Mary Ann, letter B, ni Charlie, ni Vina, ni Earl, ni Michiro. Ayan, similar lang yung mga bata natin na nagko-comment kanina pa, no? Kayo lang ang present today. Aso nang ibalagot kayo sa akin, Char. Alright, so tama po kayo. Number 3 is B, microwave. Ayan. Siyempre, kung nandyan ang radio wave, siya talaga yung list. Alright, moving on. Number 4, last 2 questions na. Which is the most penetrating, mas tumatago sa kahit saan? A, infrared, B, radio wave, C, gamma ray, and D, ultraviolet. Ayan, humabol si Crishaline, si Jam, si Ryan, si Marvelyn, at si Sino. Humabol sila sa number 3. They all answered letter B. They are correct. Marvelyn, ayan, nagtype na siya ng 4. Ano kayang answer ni Marvelyn? Ayan, retract niya yung message. Number 4, which is the most penetrating, mas tumatagos kahit saan. Aha. Or siguro delayed lang ako. Ayan, si Sheena ay nag-answer ng letter C for number 4. Sinusundan ni Mary Ann, ni Michiro, ni Justin, ni Charlie, Sino, si Vina, si Earl, si Crishaline, si Alex, si Justin, ayan, si Jam. Kanina pa nag-answer yan si Justin. And they all answered letter C and you are correct. The answer is gamma ray, the most penetrating of all the members of the EM waves. And last one, which is the fastest? Sino naman daw ang pinakamabilis? A, radio wave, B, ultraviolet, C, gamma ray, and D, none of this. Parang may mali ako dun. Alright. Sige nga, sasagot nyo kaya yan? I'm pertaining for the speed kapag lahat sila ay nagta-travel sa vacuum. Radio wave, ultraviolet, and gamma ray traveling in the vacuum. Alin kaya sa tatlong yan ang fastest? Aha. Number 5, letter C daw, sabi ni Mary Ann. Number 5 na nga pala yan, bakit number 4 pa rin ako? Sabi ko na may mali talaga sa slide na yan eh. Aha. Ayan. Okay, so si Justin lang so far ang nakikita kong tama ang answer. None of this is the fastest. Actually, mali din ako dyan. Dapat pala nilagay ko na lang all of this. Kasi lahat po sila ay may pare-parehong bilis kapag sila po ay nagta-travel sa vacuum. Kaya nga constant po ang ating V, which is 3 times 10 raised to positive 8 meters per second. Na kung pahahabain natin is 300 million meters per second. Alright, ayan. Di po, huhutay po. O nga po, di nga nakita ko nga kay Justin kanina. Ayan o, D. Yan, si Justin lang po ang tumama. Pero thank you po for participating. Ayan, number 5, all have the same speed. Sabi ni Sir Nick na naka-tune in ngayon. Ayan. Dapat talaga ang nilagay ko dyan sa letter D ay all. Alright, model time. Thank you so much, Ma'am Janice, for pressing the next slide. Model time, learning task number 1.3 and 1.4. And of course, reflection 1.1. Marami na rin nakatapos, pero keep on doing the activity. Yung problem solving nandyan sa learning task 1.4 class. Alright, samantalang, sa atin namang mga MDL students, wala silang problem solving, bongga kayo. Pero meron kayong mga guide questions na isi-send ko sa inyo kasi parang sa page 9, may pinapagawa sa page 9 na may guide questions, tas wala. Pero ako ang magsisend ng guide questions na yun mamaya. Kanina sisend ko na eh. Kaya lang nagutom kasi ako. Alright, so with that, thank you so much. Of course, sa aking mga ginamit na mga simulators, simulations, the FET Interactive, and yung Java Physics Lab, something like that. And so with that, thank you so much for tuning in. Pa-shoutout daw, sabi ni Sino. Sino yung talaga yung pangalan mo? ODL ka, ha? Kausapin kita mamaya. Thank you daw, sabi ni Charlie. May sumunod pala kay, sino to? Ano sabi ni Mary Ann? May sumunod pala kay Gamma. Wala po, lahat po sila ay mas mabibilis po. Para-pares po sila ng bilis po. Yan, tama nga po yung sinabi ni Sir Nick. Thank you rin, Alec. Kung wala na kayong tanong, thank you so much. Absent si Emerson ngayon, ha? Pinansyal ko talaga siya. Kailangan nandito si Emerson. Alright. Thank you so much. See you again next week for the applications naman, itong mga pinag-uusapan nga natin na EM waves. Alright? Sana mas maging excited kayo kasi we might be showing you experiments. Alright. Thank you so much for tuning in. Only here at Science Matters, where learning never stops. Bye-bye!